Good morning. Hello, Mr. Troa. Hello, students. How are you today? Oh, it's no problem. I just love helping out anytime I can. Yeah. Oh, look at my hair in this color. Oh my gosh, the light, it's so golden brown. Golden gold, you know. Okay. Well, what are we working on today, Mr. Triola? Introduction to dividing whole numbers by fractions. Oh, that's an exciting topic, isn't it? Are they ready? Do they need to open Nearpod or anything? Oh, look how cute they look out there. Oh, hi, kids. I love when I'm in your classroom substitute teaching for you. Anyways, would you like, yeah, I can get started. Okay. All right, let's look at the first slide here. Okay, the first slide tells us that there are 5 basic steps used when we divide a whole number by a fraction. Okay, the first step is step 1, and it is to change the whole number into an improper fraction. Okay, that simply means putting it over the number 1, right? Okay, step 2. Step 2 is to rewrite the divisor as its reciprocal, and then switch the division to multiplication. Okay, what's the little rule that they used to have when we were growing up, Mr. Triola? Ah, yes. Yours is not to question why, yours is to multiply. Anyways, let's go on to step 3 now. Step 3 is to cross-simplify where you can. Why do they do that? Oh, it makes everything easier in the final answer. I understand. Step 4 is to multiply the terms of the fraction, and then step 5 is to switch the quotient back to a mixed number in lowest terms. So there's just basically 5 steps, isn't there? Okay, should we move on? Do they have any questions? Oh, let's move on. Look at that, it's a Nearpod. Nearpod 1. Put the steps for dividing whole numbers by fractions in order. You want me to uncover? Oh, okay, I'll uncover the steps that they'll be working with. Oh, there they are. Go ahead, kids. Mr. Triola should advance the Nearpod for you right now so you can do this. And I'll pause the video. Oh, how did they do, Mr. Triola? Are they done? Yes? Oh, okay. So, very good. So, they got the steps in order. Okay, shall we move on? Okay. Now, you brought up the word cross-simplifying. Would you like me to go over that? Oh, yeah, I guess you would, huh? What does it mean to cross-simplify? Yeah, we're going to go over that. Okay, so anyways, to cross-simplify, oh, this technology, it just shakes me sometimes. No, pardon me. Oh, sorry, I had a little cough in there, little tickle in my throat. What does it mean to cross-simplify? Well, it means you prepare your numbers so you get the quotient in lowest terms possible for your final answer, because almost always teachers are going to want what, Mr. Triola? Yes, quotients or final answers in lowest terms or simplified. Okay? So it means that you simply prepare your numbers, okay? So that they are basically makes your life easier, huh? Okay? And when you do that, here's a tip. Cross-simplifying is going to be made a lot easier if you look for the greatest common factor of the numbers you're working with, okay? So, how about we show them what we mean by that? Would you like me to do that? Are they focused? Oh, okay. Let's give an example. Here we go. Would you like, there it goes. Okay, so if we're going to cross-simplify these two fractions of 8/15 and 3/4, so if we wanted to multiply those out, we would want to cross-simplify before we do. And so we're going to look for compatible numbers, like 15 and 3 are compatible. And so we would then say, okay, well, what is the greatest common factor for 3 and 15? So the factors of 3 are pretty simple. They're 1 and 3. And the factors of 15 are 1, 3, 5, and 15. So the greatest common factor would be what, Mr. Troa? Oh, yes, it would be 3. Okay, so that means we would divide by those. So we're actually front-loading the simplification. Okay, so then 15 divided by 3 is 5. 3 divided by 3 is 3. So then we would want them to find the greatest common factor of what, 8 and 4, right? Okay, so the factors of 4 are 1, 2, and 4. The factors of 8, it's a little trickier, but, you know, 1, 2, 4, and 8. Okay, so the greatest common factor would be 4. So if we cross-simplify 8 and 4, we would be dividing by the greatest common factor of 4. So that would give us 1 and 2. So now we could multiply those out, and if we multiply them, we'd have 2 times 3 is 6, and then 5 times 1 is 5. So we would have 5 6, which would be 1 and 1/5. Okay? Would you like to do another example with them? I'll erase the screen while you do. How are they doing so far? Yes. Well, thank you. How do you like my button? Pretty nice, huh? Or pin. Okay, let's do another example. Here we go. We have 3/5 times 10/27. So we want to cross simplify first, so we look for compatible numbers, and 5 and 10 are definitely compatible. So we would want to find the GCF for 5 and 10. So the factors of 5 is a prime number, so it's 1 and 5. The factors of 10 would be 1, 2, 5, and 10. So the greatest common factor would be 5, so we divide them both by 5. So 5 divided by 5 leaves us with 1, and 10 divided by 5 leaves us with 2. Okay? Are there other compatible numbers there? Should I keep? Yeah, there are. Well, of course there are. 3 and 27 are compatible, and so 3 is prime number, so its factors are 1 and 2. 27 is a composite number, so it would be 1, 3, 9, and 27. So, why did I write a 2 there? That should be 1 and 3. So the greatest common factor for 3 and 27 is 3, so we divide 27 by 3, and we get 9, and we divide 3 by 3, and we get 1, so we could multiply 1 times 2, and then 1 times 9, and we would get an answer, a product of 2 9s. Does that look okay, Mr. Triola? Okay, so everything looks good up there? Okay, would you like to move on? Oh, I sense a Nearpod coming on too. Hey kids, let's do Nearpod 2. Cross simplify and solve this problem. Be sure your final answer is simplified, okay? Because those tricky teachers, they're gonna want it simplified. Okay, Ms. Sherrill, would you please pause the video while they do this problem? I'll open it up right now. And then you can pause the video. Oh, I'll just slide it off. Pause the video, please. Okay, are we all set? Okay, good. All right, so we want to multiply 3/4 times 6 9ths, okay? And in order to do this, we want to first cross simplify. 4 and 6 are compatible numbers. The greatest common factor would be 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Then we could cross simplify 3 and 9. 3 can be divided by 3, and 9 can be divided by 3. So now we can multiply over. 3 times 3 is 9, and 2 times 3 is 6. Uh-oh. Do we have to do something else to our answer? We sure do. We have to make it into a mixed number. So now we would take and divide them. Now we would simply take 9 divided by 6, and 1 times 6 is 6, subtract and you get 3. So we have 1 and 3 6. Now notice that our cross simplifying didn't completely eliminate simplifying the last part of our problem. So we're going to have 1 and 1/2. And it's much easier to simplify 3 6 to 1/2 than it is a bigger problem. Okay? Should we keep going now? Okay, here we go. All right. You want me to talk to them about what a reciprocal is? Ah, very good. Let's do that. It just won't go away sometimes. So I'm just gonna slide it off. All right, so a reciprocal is two numbers whose product is 1. Here are a couple examples for us, okay? Our first example would be 3/4, okay? So its reciprocal would be simply to take this 4 and turn it into the numerator and take the 3 and turn it into the denominator, and that would create its reciprocal. So that means that if we do 3 times 4 and 4 times 3, we're going to get a product of 12 over 12, and that means that you have 1, because 12 twelfths would be equal to 1. Should I do another example? Oh, okay, I'll do another example with them. Let's use this fraction. Yeah. Oh my, that's a big number, isn't it? Okay, what would the reciprocal be? Ah, you're right. The reciprocal would be 54 over 37. And remember, if we multiply these, they're going to give us a rather large set of numbers to work with. 1,998, 1,998. Wow. But really, that's just going to equal 1, isn't it? Because this and that's the reciprocal, and two fractions multiplied together, which have a product of 1, are reciprocals. Okay. So, anyways, did I explain that well enough for him? I felt a little confused myself, but anyways, a reciprocal just means you flip-flop things. Do you want? I sense a Nearpod going on too. Oh, here we go. Give the reciprocal for the fraction 6/7. I'll pause the video. Oh, how did they do? All right, would you like me to show them how to come up with the reciprocal? Well, of course, simply the reciprocal for 6/7 would simply be 7 over 6. And of course, if we multiplied those, we would have 6 times 7 is 42, and 7 times 6 is 42, which, if simplified, would be 1. Okay? Do we want to go on even more? Oh, okay. All right, let's try. I think we're ready for actually dividing. Do they look ready? Are they ready for some division? Oh, wonderful. Good. Let's review the steps first. I think that's a good idea. Don't you, Mr. Triola? Yeah, I know. They do look a little tired. That one's not paying attention. Do you want me to come into the classroom and... No, okay. All right, let's go over the steps before they get too tired, okay? The basic steps used to divide a whole number by a fraction in review would be step 1. You change the whole number into an improper fraction. Step 2, you rewrite the divisor as its reciprocal, and then you switch to multiplying. Yours is to invert and multiply, not to question why. Step 3, cross-simplify where you can to make your life easier. And then step 4, you multiply the terms of the fractions. The terms of the fractions, all right, so if we were dividing something like this, okay, we would, first of all, let's give them a whole number real quick. Let's give them a whole number here, okay? Let's say if we were, what you want me to give them? 4 divided by 3/4. Okay, so step 1 is you change the whole number into an improper fraction. And step 2, you rewrite the divisor as its reciprocal. So 3/4 becomes 4 over 3. And then you switch this to multiplying. Then you cross-simplify where you can, but we can't cross-simplify in this example we came up off the top of our head. So now we multiply the terms. So these numbers, the numerators and denominators, are simply the terms, okay? So 4 times 4 would be 16. 1 times 3 is 3. And then, of course, the final process is to switch back into a mixed number in lowest terms if you can. So, of course, 16 divided by 3 would give you 5, with a remainder of 1. So that would be 5 1/3. Okay, so that's the steps basically. Okay, so you just wanted me to make sure they understood what the terms were. Okay, so the terms, okay. Would you like to do some Nearpod example problems now? Okay, I'll move on. Let's give them some then. Okay, let's try, ooh, my. Let's try this one, Nearpod 4. You ready, kids? Do they look ready? All right, here we go. 12 divided by 2/3. I'll pause the video, Mr. Triola, or you pause the video, and then I'll go over the example for them. Are they ready? Okay, good. Here we go. All right, step 1, kids. Okay, we have 12 divided by 2/3. First thing we want to do is turn 12 into an improper fraction, so we have 12 over 1. And then what we want to do is we want to make the reciprocal of 2/3, which would be 3 over 2, and then turn our division into multiplication. Now we can cross simplify, and we see that we have compatible numbers. 12 and 2 are compatible numbers. 2 can go into 2 1 time. 2 can go into 12 6 times. 3 and 1, they're both, they're not compatible. You don't have any greatest common factor there. So we can just multiply. 6 times 3 is 18, and 1 times 1 is 1. And then the final step is to make a mixed number, or in this case, simply a whole number of 18. How did they do? Oh, they are very bright, very smart. Would you like to try another example problem? Okay. Let's try this one. Oh, I bet it's going to be a good one. How is it? Yeah? All right. Are they ready? You pause the video, and then you kind of like let me know when you're ready. Are they all set? How'd they do? Oh, they're so smart. You must have really prepared them. All right. Would you like me to show them the answer? I get so excited when I do this. Okay. First thing we want to do is take 9 and divide it by 6/5. Okay, 9 divided by, ooh, there's a little mark down. I'll get rid of that. So we have 9 divided by 6/5. That's kind of weird. 6/5, that's an improper fraction. Oh, so it would be the same as saying something like this, 9 divided by 1 1/5. Oh, I see. So we just simply have a mixed number written as an improper fraction. And so they can still go ahead and divide. So if they get something like this, they should turn it into an improper, never mind. Okay. So anyways, let's do this. Let's bring the 9 down, and then we'll create the reciprocal of 6/5, which would be 5 6. And then we turn that pesky division symbol into something easier, like a multiplication symbol. And now we have to make 9 our improper fraction. So now we're all set for compatible numbers, aren't we? Okay, so we do have some compatible numbers. We have 6 and 9 are compatible. They can both be divided by 3. 3 will go into 6 twice. 3 will go into 9. 3 will go 3 times. So now we can multiply 3 times 5 and get 15. And then 1 times 2 is 2. Are we done? No, you're right. They have to turn it into a mixed number in lowest terms. So that means that we take 15, because 15 halves is nothing more than a division expression. 15 divided by 2 would be 7 times 14 with 1 remainder. So our final quotient would be 7 1/2. Well, Mr. Trilla, I think I'm going to call it a day. I'm going to go walk my dog now. Bye, kids. You have a good day. Is there anything else I need to talk about, or do you want to take over now? Thank you for inviting me. See you, kids. I'm going to go walk my dog. Patty, would you like to go for a walk? Oh, of course we can go for a walk. Let's go.